right, so we're going to finish 1-4 today. We're going to do some operations of complex numbers. Add, subtract, multiply, divide. This is preparing us for our next section, which is solving quadratic. Okay, so when you're adding, if there is a plus sign between your two parentheses, you are just adding like terms. Take off the parentheses. You are not multiplying. The only reason why there's parentheses there in the first place is just saying add this number plus this number. Okay, so take off the parentheses and then you're just combining like terms. So I'll do that step first, and then we need to simplify our radicals. Okay, so I can pull out an I when you have a negative under the radical, and then 72, let's write that as 36 times 2. So you're doing negative 7 minus 6i squared root of 2. And then for this one, pull out the I because it's a negative under the radical. And let's write square root of 50 as 25 times 2. So that's 5i square root of 2. We good so far? Okay. Let's combine like terms. We have to write this in a plus bi form. So we need to combine our real parts. So the real parts are negative 7 and 8. So negative 7 plus 8 is 1. And then negative 6i plus 5i, negative 1i. And I also have like radicals. So I had to have i's and like radicals in order to combine those. So that's negative 1i or negative I radical 2. Now you have a plus bi. It's okay that your i's here. If you want to put the I at the end, you can, but like I said Friday, make sure it's not under the radical. Questions about that one? So when you add, take off the parentheses, and then you're combining like terms. When you subtract, there will be a subtraction sign in between. You want to distribute the negative and then add. Okay, so let's distribute the negative first. So this negative here does not cancel with the negative 8 under the radical. It's under the radical, so you can't put those together. Okay, let's go through and simplify each of our radicals now. So square root of 3 is just square root of 3. What about square root of negative 2? How does that simplify? Yep, you have to pull out the I. Square root of 12. So 12 is 4 times 3. So how would I simplify square root of 12? 2 square root of 3. Good, because square root of 4 is 2. Okay, minus. First of all, you have to take out I because of the negative 8. And then 8, it can be written as 4 times 2. So how does 8 simplify? 2 square root of 2. Good. Okay, combine your like terms. Does square root of 3 have a like term? Negative 2 square root of 3. So 1 square root of 3 minus 2 square root of 3. Negative 1 square root of 3. That's the real part. Now I look at my imaginary parts. Is I square root of 2, is this a like term? Can I combine those? Yes. So 1I square root of 2 minus 2I square root of 2, negative 1I square root of 2. So even though it's a radical and it's negative, that's still a real number. There's no I there. So this is still A plus BI4. We are done here. Okay? If there is an addition or subtraction sign in between your parentheses, you are not multiplying. Do not multiply. Do not try to FOIL these. That is not what you're doing. You're just subtracting. Distribute your negative, and then we combine like terms. So this looks complicated because there's fractions, but this is actually easier than the ones we just did because there's no radicals. So I have positive 11, negative 7/15 I. So I don't have any radicals to simplify, so I just combine my like terms. 3 plus 11 is 14. 3/5 I minus 7/15 I. Just put that in your calculator. You're just adding those together. All right. If it were to give you a mixed number, it must be written as an improper fraction. This one's not, though. This is just a normal fraction. Okay, if you're adding these, 3/5 is 9/15, right? 9/15 minus 7/15 is 2/15. So it's okay that you have a fraction in your answer too. Fractions, radicals. We just have to make sure it's written as A plus BI. Good. Questions about that? Okay. We're going to talk about multiplying now. Okay, A plus BI4. I don't have an operation like addition or subtraction, so I know I'm multiplying these. So what do you think we use to multiply? Yeah, FOIL. If it's 2 terms times 2 terms, we're going to use FOIL. So I have a negative 12. And then my outer, negative 4 times positive 2 is negative 8i. My inner negative 2i times 3 is minus 6i. So you can multiply a real and an imaginary together, but you cannot add or subtract a real and imaginary together. All right, negative 2i times 2i. Well, that's negative 4i squared. Okay, negative 12. Combine your like terms. That's negative 14i. And then you always have to replace an I squared. What should you replace I squared with? Negative 1. So what we have is negative 12 minus 14i plus 4. And then you have like terms, negative 12 and positive 4. That's negative 8 minus 14. And that's a plus bi. Okay. Good. You are subtracting inside the parentheses, so you cannot distribute your exponent. That is wrong. Do not distribute that too. You can only distribute if you are multiplying or dividing inside. Okay? So write it twice and use FOIL. Let's do that first. And then I will remind you of the shortcut to square binomials. So go ahead and multiply those, work through that. So, you get 4 plus 20i plus 25. Negative 25 times negative 1. Yeah, thank you. Thank you. So minus 25 then. Negative 5 times negative 5 is positive 25. 4, so negative 21 plus 20i. That's what you should have gotten. Okay, when you square a binomial, the shortcut is a squared plus 2ab plus b squared. So, you know when we did the sum and difference of cubes, it didn't really matter if a or b were negative, you just followed the signs exactly. Well, when you do this, we are going to pay attention to the signs when we square our binomial. So if I take negative 2 minus 5i squared, so this is my a, this is my b. So a squared, negative 2 squared is positive 4. I'm going to do a times b, so negative 2 times negative 5 is positive 10i, and then times 2, so plus 20i. And then this squared, that's positive 25i squared, which is negative 25. And then, So this saves you some steps if you can remember the shortcut. We will use this shortcut continuously throughout the year, so at some point it's good to memorize. But if you don't have it memorized yet, you can write it twice and use FOIL. Okay? Okay, let's talk about conjugates again. Whenever we divide complex numbers, we can't write it in a plus bi form without getting rid of the complex number in the denominator. So what's the conjugate of 2 minus I? 2 plus I. So remember, it's just the exact same except switch the sign of the second term. All right, and then it says find the product. So we want to multiply these together. You can FOIL. If you have two binomials, you can always FOIL. But if you also can remember, the shortcut for multiplying conjugates was a squared minus b squared. So a is 2, so 2 squared is 4, minus b is I, so I squared. Well, what is I squared? Negative 1. So actually you're doing 4 plus 1, and we just get 5. The purpose is to get rid of the I, so this should happen every time when you multiply conjugates. You should get a real number. So when you do complex conjugates, so this doesn't work when you're doing radicals, but complex conjugates, meaning there's an I, what you're actually doing is a squared plus b squared. So you can use either a squared minus or plus. If you do the a squared plus b squared, then that's already taken the I out. So your a would be 2, your b would just be 1. A would be 2, b would be 1. So it's a little bit shorter if you use this, but you just have to be careful on getting confused with the signs or that you're ignoring the I. This already takes the I squared into consideration, which is why it makes that a plus. Well, first of all, what is negative 5i as a complex number? What is negative 5i in a plus bi form? 0 minus 5i. So if you think of it as a complex number, writing it with the 0, then the conjugate isn't too difficult to find. The conjugate would be 0 plus 5i. Alright, so if I do the a squared plus b squared, because they're complex numbers, I'm ignoring the I. Corey, can you put your Chromebook up, please? Thank you. Alright, so a is 0. B would just be 5, so plus 25. Okay, and that's just 25. So if you think about it, you're doing negative 5i times 5i. That's negative 25i squared, which would be positive 1. Okay? Yes. Yeah. Okay. So we're gonna, I'm gonna come back to this page, but let's go here. The reason why we use the conjugate is so we can write it in standard form. So standard form of a complex number is our a plus bi. So if this had been written the other way around, so if I did the reciprocal of this, to write this in a plus bi form, you're just separating like this. So then you'd reduce your 3 over 6. Okay, it does not work the other way though. You can separate a numerator, but you cannot separate a denominator. You cannot do this. So the reason why this works is because you can put them back together because they have a common denominator. But here, if you try doing this, you couldn't put those back together because they don't have a common denominator. The value would not be the same. So it doesn't work in reverse. You can separate a numerator, you cannot separate a denominator. So to write it in a plus bi form, you need to get that I out of the denominator. So you have to use the conjugate. So because there's a plus, don't forget those parentheses are there. I need to multiply by the conjugate. So what's the conjugate of 1 plus 3i? Good. So 1 minus 3i. 1 minus 3i. Let's see. So on top, I should distribute. That's how I will multiply. So 6 times 1 is 6. And then 6 times negative 3 is negative 18i. Okay, when I multiply complex conjugates, I can do a squared plus b squared. Remember, b ignores the I. So a is 1, a squared is 1, plus b is 3, so b squared would be 9. Okay, so you get 6 minus 18i on top. And on the bottom you have 10. Now you can separate, so it's an a plus bi form. You could reduce before, if you factored out the 6, you could reduce with the 10, or you could just reduce here. So 6 over 10 is 3/5, and 18 over 10 would be 9/5. Okay. All right, let's practice another one. what's the conjugate that I use? 2 plus 5i. So distribute in the numerator. Uh, 3 times 5i would be 15i squared. The denominator, a squared plus b squared. So a squared would be, b squared would be 25. So even if b you say is negative 5 and not the positive 5, negative 5 squared is still 25, positive 25. But I have an I squared. So you have to make sure you replace this I squared with negative 1. So I'm going to write that first. That's negative 15 plus 6i over 29. I wrote the negative 15 first because when I separate I need a plus bi. Okay, and then separate. I wouldn't want to factor out first because nothing would cancel with my 29. So that's why sometimes it's helpful to wait till the end to reduce. Because now neither one of these reduce. Questions about those? All right, we're going to look at one more type of problem, and then we will do some practice on the whiteboards. So they give me a value of x, and I want to know if it's a solution. So I'm going to substitute that in for x. So just like with real number values, anytime you plug something in for x, you plug it in with parentheses. So here's my value, and I need to substitute that in for x. And in this quadratic trinomial, I have two places where there's an x. So I'm plugging that in. And if it's a solution, then it will equal 0. So I'm going to write this. I'm going to put a question mark over the equal sign, and I'm asking, does that equal 0? Because if it equals 0, then yes, it is a solution. If it equals any other number, then no, it is not a solution. All right. So for this first part, write it twice and use FOIL, or do the shortcut. Okay. So if I do the shortcut, this is why having this memorized is helpful, because you use it inside other problems sometimes. But you can always write it twice and use FOIL. So negative 3 squared is 9. Okay, 2ab. So a times b. Negative 3 times 2I is negative 6I times 2. Negative 12I. And b squared is 4I squared, which is negative 4. So then this is 5 minus 12I. Okay, for this part, I just have to distribute. I'm going to bring that down here. Negative 18 plus 12I. And carry down your plus 13. And I want to know if that equals 0. 5 plus negative 18 plus 13. 0. Negative 12I plus 12I is 0. 0 plus 0 does equal 0. So then I need to say yes, it is a solution. So you need to answer yes or no. Questions about that? So in our next section, 1.5, we're going to be solving quadratics. And sometimes we get complex solutions. Well, we can still plug those in to check that we got our answers right. Okay. Okay, so we're going to stop there, and then we'll do a few whiteboards. Mm-hmm.